Hello. Right. So today we continue with our revision on the checkpoint 4 to 7. I think we ended yesterday trip on number 30, I think. So we might as well start. No, we did 31. We're now at 32. Right. We're going to discuss the correct answers. We're also going to discuss the wrong answers, so that I think we just cover everything that has been discussed in chapter 4 to 7. So starting with number 32, examples of cut-through switching. We might as well start with the two types of switching methods that we have. That one, cut-through, what's the other one? How does a switch
Current
switch?
forward.
There is just
Forward.
forwarding.
Yes. So this eliminates this answer because those are two different methods. Briefly, what does cut-through and store and forward do? Those two methods. How do they switch? How do they forward, basically?
Okay. Store and forwarding. It waits for the for the full what's that? The
Frame,
full packet.
frame.
Kuti chitanga kusvika rese rakakwana, then it forwards it. Then it
Yeah,
forwards it
it's
to
called a
the
frame, not a packet. A frame,
to the receiver. A frame, sorry.
yes. A frame layer 2, packet layer
So
3.
okay,
You can
okay,
continue,
yeah,
you can
yeah,
continue.
understood. Okay, so it waits for the whole for the whole frame to be complete. Then it forwards it as a complete package. Unlike unlike the other one, the cut through one, it doesn't wait for the whole frame to
What does it wait for?
for it
It waits for
to forward
something.
to forward to the receiver.
It waits for something. What does it wait for?
Uh, for the receiver information.
Yes, the destination MAC address. Once it has the destination MAC address,
Market.
yeah, then it can send this information. Right, I would love to eliminate this. We don't have this type of switching. We don't have this. So we are only left with these two. Fast forward switching and fragment-free switching. Those are two examples of cut-through switching. Who knows what's the difference between fast forward and fragment-free? What's the difference between those two?
I would like to go again. I hope I'm still going to talk.
Feel free to participate. We had a session yesterday and Tansina Wanogaita say, I think Sharon was the only one. Let's give it a go. I think it's more interesting when you participate.
Okay.
Andy.
Okay, fragment free. This one, okay, fragment free. I think it just waits for a piece of the fragment, not the whole fragment. Then checks for errors and then forwards it.
And fast forward.
And fast forward it just forwards I checking my errors. It doesn't check for errors or wait for anything. It just forwards by just receiving the destination MAC address. It just forwards it.
All right.
So actually verifying.
Yeah, I think you pretty much close.
Hello?
What's fast forward is yes. You want to add in?
I was thinking fragment free is just the one that check the first I can't remember how many bytes of the frame. Then if it's error free, then it forwards it without checking the whole frame. Then fast forward switching is it just checks the destination mark and forwards.
Okay. Right. So I think we're confusing the two main type of switching methods that we have. We have this one, the store and forward, which checks everything, including the errors, then forwards. Then we have cut through, which does not check uh, the errors. It only checks the destination mark. So those are the two main methods of switching that we have. Then with cut through switching, there is I think there is a compromise between how fast, let's talk latency, how fast the network needs to be. With cut-through switching, we have these two types, the fast-forward switching and the fragment-free switching. And it all depends on how fast you want the network to be and how reliable you want the network to be. So you need to find reliable. You need to find a balance between the speed and reliability. So cut-through switching, if we're talking general, cut-through switching, it's very fast, but also not reliable. Why? Because it is not checking errors. However, with this version of fast-forward switching, it does not check errors at all. Therefore, it prioritizes latency, speed. Then with the fragment-free, it checks for errors. At least it checks for errors. The speed is much less, but it is a bit reliable. So I think at the basis of those two, store and forward and cut through, one is very much reliable, very reliable, this one, but slow, right? It's very reliable, but slow. Then cut through switching, not so reliable, but fast. And with these two, the fast forward and the fragment free, those are sort of methods, sub methods, if I can say, of cut through switching, where we are trying to find the compromise between speed and reliability in cut through switching. Now, the important thing is understanding application. We have applications where reliability is much needed. We also have applications where speed is much needed. So where you need speed, for example, in streaming, you need that speed. So you have to use fast forward switching. If for another example where speed might not be necessary, but reliability is necessary, you would then use the fragment-free type of switching. I hope I'm making myself clear. The type of switching methods we choose depends on the application that we want to have. Panarasi.
Yeah, no, I think if you're going to chitongoti vharo zvedu kuti tikwanise kuzopindura, but otherwise apa ndozvakanaka kutaura chaizvo ndo zvatakaverenga chaizvo.
All right, proper. Let's move.
Ndaida kutaura even pataura
33. Which frame forwarding method
even
receives the entire frame, performs CRC check, detect errors before forwarding the frame? We've dealt with that one. Store and forward, B. All right. Hello, Sharon. How are you? All right. What is the purpose of the FCS field in a frame? I think we had a discussion yesterday on checksum. There was checksum and CRC FCS. And I think we concluded these two are ways of error detection, with one operating at layer 2 and the other one operating at layer 3. There we have FCS again. What is its purpose? To obtain the MAC address? No. To verify the logical address? Right? When you see logical, think layer 3. Every time you see logical address, think layer 3. To compute the CRC possible answer, to determine if errors occurred in transmission and reception. What's the answer here? These answers look like they both can be the correct answer. Number 34.
I think it's C.
Why? Why not D?
Because until FCS ndio inoita zve-error checking, official FCS inenge ine CRC
Yes.
yekucheka ma-errors.
Does it not also determine if errors have occurred during transmission and reception? Data integrity, I think we talked of data integrity yesterday. Memory barrier. We talked of data integrity yesterday. Does D not define data integrity if information has been tampered with? Therefore, we have to detect if it has been tampered with. That is part of error check as well. Does D not work? Hello.
Yeah, in I would go with the D.
Why?
Yeah, because the D, via verifier, my errors actually see like the error okay from like authenticity and the transfer at time.
Integrity. I prefer integrity, not authenticity, because authenticity defines something else. Right. My answer, guy. If you look closely, answer here ukangotarisa CRC inoita kunge answer iri correct. But if you look at what follows CRC, pane CR to compute the CRC header. Makamboverenga nezve-CRC header and the CRC for the data field as well. Makamboverenga nezve-CRC header at any point. Ndianapindura anenge gufe, ndianapindura. Judith. My answer, they might sound. Wamboverenga nezve-CRC header. Let's go back. I think let's go back for CRC. Just a minute. I think it might help. Right. Then the cholesteric fields, FCS. Right? Used to detect errors in the frame, it uses the CRC. The sending device includes the results of a CRC in the FCS field of the frame, not the data field. Let's start there. It does not work in the data field. Data field is not irrelevant. Amana SC, amana CRC. This way. Are we agreeing? CRC yangopfekerwa, but muanse momo mune zvinhu zvana data field where CRC haifanira kupfekerwa. Iwewe wangoona CRC and that looked like the answer to the question. Right, let's look at what CRC does. Detect errors, use the CRC. The sending device includes the results of CRC in the FCS field. The CRC is in the FCS field, not in the data field. The receiving device receives the frame and generates a CRC to look for errors. If the calculation match, no error occurred. Calculation that do not match are an indication of data that has been changed. A change in the data could be the result of disruption or electrical signals that represent the bits. Errors result from data that has been changed during transmission. So if we have data, let's go back to our question. If we have data, what basically CRC is a number. If you've ever done security, there is what we call hashing. CRC, it sounds a lot like hashing. Where are we? Number 30. All right. So basically what it is, at the transmission side, so we have the transmitter and the receiver. Right? When we get our data, this data is used to calculate the CRC. The CRC is just a number. And let's say our data gives us a CRC of 2. What is happening with my today? Let's say it gives us a CRC of 2 after we calculated the CRC. So when we transmit, this CRC of 2 is in the FCS field. No matter is what that number in the FCS field. Then partner transmission, final receive hapana. You know the error check. Patinopinda mu layer number 2, panochekwa the FCS field in the receiving end. Inocheka kuti number iri apa ichii. Kana isiri 2, it means data has been changed. That's where the error comes in. So CRC field E data parinosvika kunoko rinocalculatwa izvo CRC inocalculatwa kunoko. Yacalculatwa yobuda iri 1. Yabuda iri 1, then yochekwa yokompewa neyabva kunoko. Dzikangosiyana ndo zvinoreva kuti data has been tampered with. I think zvema CRC they are more advanced for this level.
Great. How are you
But
doing?
I'm just trying to make you understand
Thank you for the salad.
how it works.
Let's see the full order.
Right. So I think basically this is it for CRC. That's how errors are checked. So in summary, data redu, we calculate a CRC value. That value rover RISCOM FCS. RISCOM FCS, patinosvika ku the receiving end. CRC yobva calculated again in the receiving end. The value inenge yawanikwa in the receiving end yokompewa nevalue inenge iri mu FCS field from data rasendwawo. Akafanana, it means that data has not been tampered with. Akasiyana, that data has been tampered with. Ndo panobva error yacho. So kuma answers edu atawana, C is incorrect because 1, the CRC header is not for the data field. Right? It's not for the data field, but the FCS field. In data field, we only have our payload, our data, and only that. That's why this answer is wrong. Although in a genus is familiar like the CRC. All right, let me see chat. Sharon wanted the mic. Okay, we've got that one. I go with the D. Let's continue. Pabatikere CRC. The reason why we went with the D. Everything clear? Hope so.
Yes, but clear.
Right, which switching method has the lowest level of latency? Define latency. What is latency? Those terms are very important in understanding how a network functions. What is latency? And what does it mean to have a low latency and a high latency? Anyone? Okay. Signal degradation. No. Latency is signal degradation. No, I don't think so.
I think it's the amount of time. Yeah, kuti data travel from one point to the other.
Exactly. And what does it mean, canary low? What do we desire for our networks? To have low or high latency?
Low latency.
Exactly. Latency is the difference in time between ono sender nepano receiver data. Right. So which switching method has the lowest level of latency? Store and forward out in a high latency. Correct? Because it just store data also D fast forward. I think so too. I'm not so sure why I guys are cut through Panap. Because these two, it cut through. The two is C and D. We agree D fast forward. I think so. I think so. Let's move to the answer for that one. I think we have to agree with D. It can be A or a D. Right, let's go. D it is. Number 36, a network admin connecting two modern switches using a straight-through cable. The switches are new and they've never been configured. Which three statements are correct about the final result of the network connection? The link between the switches will work at the fastest speed that is supported by both switches. Right, I'm not going to read all the answers.
The link
My
between
answers, eh?
switches will work at the fastest speed that is supported by both switches.
Right, this can be correct.
Yes, A is correct because of the auto negotiate speed.
Exactly, auto negotiate.
A,
I think modern switches is key because my switch data they didn't have that. The link between switches will work at full duplex. Question mark on this one. What if one is half duplex? What is happening with my pen today? All right, see if both switches support different speeds. They will each work at their own fastest speeds. This one is wrong. The auto MDX, let's eliminate some answers here. Auto MDX feature will configure the interfaces, eliminating the need for a crossover cable. That might be true. Question mark. The connection will not be possible unless the administrator changes the cable to a crossover. This is wrong. That's what I'm Mangana. Right? The duplex capability has to be manually configured because it cannot be negotiated. Can the duplex be negotiated? At A and D, right? We need 3. So that A, D, but we need 3. We need 3 answers. Where do we get those 3 answers? A,
pamaramba B uyoyo ndofunga kuti B uyo zveshuwa anenge ari correct.
B tamisa question mark.
All right. Asi saka tangobata A, B na D.
A, B na D. Why not?
Yeah.
Why not F? I think there is a choice between F and B. Why not F?
I'll go with F because of previous experience somewhere. If let's say we are using my SFPs that are connected, we are using Kika Ethernet port, or we are using my ports that are at different speeds. The other one is a 50 meg and the other one is a 100 meg.
Yeah.
And the cable doesn't support that particular speed. It has to be configured manually on the other port that is a low speed for it to accept the speed of the other port.
I see F. That doesn't explain F.
Yeah.
I think kuti pane keyword runs modern switches, it means that maybe they are most likely of, if they are modern,
Full duplex.
that means they are operated as full duplex.
Full duplex. Okay.
And most probably Kanarima switches are connected to each other. That means that they're mostly using the same medium. Canary fiber potence. Saka speeds I think utanga chingoenderana. Anogona mechana akadaro.
Yeah. My speeds are not different on my ports as well. Let me highlight that. Even if medium is the same, one end on 100 megabytes port. Hey, my pen is not working today. 100 megabytes. Then the other side we can have 1 gigabyte. So my speeds they can be determined in my ports as well.
Okay, I don't think the pen is the same you use every day. Machinja pen in that.
I see.
You atwanza kuona pen yakarebesa nasi.
Do I tell Shansan and Zuro because I'm writing on this PDF thing. Let's continue. I think for this one, A can work, definitely works. B works, Tatinishi ne D. A, B, D. Permanent revision, make sure to get my answer correctly, Papa. Was in this to yedu. Number 37, advantage. Which advantage does the store and forward method have compared to cut through? Frame error check, that's an advantage. Faster frame, store and forward is not fast. Frame forwarding using IPv4, hakuna issues. We didn't learn about that. Does store and forward detect collisions? I don't think so. Anyone name my answer besides B? I think B is correct. Anyone name my answer? I don't think so. Right, 38. When the store and forward method of switching is in use, what part of the Ethernet frame is used to perform an error check? CRC in the trailer, right? Source mark, no. Destination mark, no. Protocol type, no. Answer by elimination, I think no one against that one. 39. Which switching method uses the CRC value in a frame? Cut through, no. No error check. Fast forward, no. No error check. I think between these two, this one, no. Cut through, obviously, store and forward. C. Black Russian glove, no. Definitely not C. Fragment free, D. Let's look at let's look at a fast forward and a fragment free. I want to see the main differences between those two. Allow me to a picture. Fragment free in a auto MDX. Right, I want to see the difference between how they explain the difference between fragment free and a was in my head. I know they were trying to find balance on latency and reliability, but how were they doing that? I think there was some sort of error check with fragment free. I want to be sure. Right. So in fast forward, it offers lowest level of latency. Fast forward switching immediately forwards a packet after reading the destination address. Because fast forward switching starts forwarding before the entire packet has been received, there may be times packets are relayed with errors. Okay, we know that one. With fragment free, the switch stores the first 64 bytes of the frame before forwarding. Why? I think information, when we are examining. Why store the first 64 bytes? What's so important about the first 64 bytes? It can be viewed as a compromise between store and forward in fast forward switching. The reason free switching stores only the first 64 bytes is that most network errors and collisions occur during the first 64 bytes. Which frame fields fall under the first 64 bytes? Teacher Shigego. I think we'll get to see why errors fall under the first 64 bytes. Right, fragment free tries to enhance fast forward switching by performing a small error check on the first 64 bytes. Dakona kuti first 64 bytes pane chi and CRC value yekutrailer uku inenge iri mumabytes api acho exactly. Right, let's go back to frame structure yedu. Let me try to find Inema bytes. I think it should be there somewhere. Okay, that's the MAC address. I hope you get exactly what I'm looking for. That's the purpose of these discussions. Right, first 64 bytes. So tine 8 plus 6 plus 6, that's 20, 22, 22 plus 46. What's 22 plus 46?
Hapo kama si 8 plus 6 plus 6 haisi 30.
It's 20. It's 20. 6 plus 6, 12.
Alright.
20. So 22 skapana. This is the frame type. Wrong. I want to see.
Then plus
So
plus
pana
46 no by the 68. No by the 68.
plus 46 I.
No by the 68.
Alright, saka my errors are one papa. First 64 bytes. Why first 64 bytes? I want to be very sure why the first 64 bytes. And where are the errors? Right, that's a question for you to research. I think in Gagarapa Syntheters or research as well. Why fragment free it will check my errors for the first 64 bytes? Definitely I do shike kuno. Because kantato kuno, I think tato more than 64. But anyway, I hope you get exactly the type of question I'm asking. And these are the type of questions you should be asking yourselves as well. Permanent revise. If you don't do that, Zamaresi seneri no feeling I won't lie. I won't lie. Kana nenda kapinda Zamero ndoko no branda kafiringika. And you hear when I start out, let's start with CCNP. Bon. Right. Panane answer. What do we have? Most network errors occur during the first 64 bytes or network collisions. Why? The question is why. We got that, but why? Why? I always like questioning why. Why in the first 64 bytes? Okay, let's have, I think, two more. What are the two actions performed by Cisco switch? Building a routing table? No. Routing table layer 3. Using the source MAC or frames to build and maintain the MAC address table. Right, what information is used to build the MAC address table? There is two information that is required to build the MAC address table. Which information is that? Very important, that question. Ichi?
What number?
What number Nishi?
The destination mark.
No.
The
What
source
number?
mark.
What number the source? That's very important. So incoming port in the source MAC address, those zinoshandiswa to build the MAC address table. So ukaenda MAC address table, what you have is the port number and the source MAC. Kwabva frame racho. Okay, very important. So this one is true. B is correct. Forwarding frames with unknown destination IP address to the default gateway. Right, unknown destination IP addresses. Forwarding frames with unknown destination IP addresses to the default gateway. Is this correct? Question mark this one. We'll get to discuss this one. Question mark. Right, let's eliminate some more. Utilizing MAC address table to forward frames via the destination MAC address. That one can be correct. So let's put a question mark. Examining the destination MAC address to add new entries to the table. This one is not correct. All right, so B is definitely correct. Now, nyaya pa C and D. Tipe my explanations, Tinso. Choice yako between C and D and explanation for why is the answer or why you're eliminating the other one.
I
In,
think for D, I think for D, is it on a local area network when you're sending on the same network, you use MAC addresses to send. So the switch is responsible for forwarding those frames to via the destination MAC address to the other client.
All right, very much convincing. Use the other one to eliminate C, Tinso. Tipe evidence, you eliminate the C.
All right. So for C, if the destination MAC address isn't on the MAC address table on the switch, it will forward it to the default gateway. The default gateway is the one that is going to forward it to a different network.
Okay.
Okay.
And I answer bad. And how do we eliminate C? Those are no bad. Why is C wrong? Because you also told us niggas are gonna find the answer is C. Why is C wrong?
Okay, quick one kata. Abantu kufunga kuti nini pasi apa pa the fact kuti mention ama IP address pa switch. I think ndopateta kuti ndopata kuti eliminate C papo because a switch normally deals with MAC addresses.
Thank you very much. I think that's the simplest way to deal with that one. I think time